Hi, grade 9s, Ms. Brown here. I just want to go over perpendicular lines with you today. And this is one of my favorite topics because if you don't look at it from a memorization standpoint, it's actually pretty cool when you look at the graphs and you look at what's happening in terms of the slopes and the rate triangles and all that kind of stuff. So we're going to go through some animations today to hopefully make that a little bit clearer. But I want you to keep in mind throughout this that it's important to understand the why behind mathematics always. And so if you can remember these visuals, you won't forget what the rule is for perpendicular lines, rather than just trying to remember the rule, because memorization without anything attached to it tends to kind of fall away if you don't reuse it all the time. Whereas if you have visuals and memories attached to it, you can usually remember it for a lot longer, and then you can apply it to more things. So that's what's kind of key. Okay, so as you can see here, we have one line, and we're drawing a rate triangle for that line and looking at the rise and the run to get the slope. So the rise is -5 and the run is 2. And if we look at the entire slope for that, then again, slope is rise over run. So the rise is -5, the run is 2, so that is our slope of line 1. Now the line rotates 90 degrees. And when we rotate the line, we can think about that rate triangle rotating as well. So now we have a run of 2 and a rise of -5. Except we're going from left to right now. It's not negative anymore. So now we have a rise, now we have a run of 5. The 2 and the 5 numbers didn't actually change, which is pretty cool. So now our slope becomes 2 over 5. Same values, one of them has a different sign. So my overall slope started as negative, now it's positive. My denominator became my numerator, and my numerator became my denominator. My rise became my run, and my run became my rise. I'm going to restart, and I'm going to do that a little bit slower. Okay, so here we go. You can see first I've drawn what I'm going to call line 1, and I need to find the slope of line 1, so I'm going to draw my rate triangle. I'm going to draw my rise and my run for this rate triangle. Notice my rise is negative, because as I go from left to right, that line is going downward. And my run, we always think about that as being positive because we're always going from left to right. So my rise here is -5. Over top of my run of 2 gives me my slope of line 1. Notice how I've put that little subscript 1 there that denotes which line we're talking about. Okay, now you're going to see something really cool in a second. We're talking about perpendicular lines. So perpendicular again means 90 degrees from each other. So we just rotated that line 90 degrees. If we rotate the line 90 degrees, the rate triangle was attached to it. So the rate triangle actually rotated 90 degrees as well. The side lengths haven't changed at all. So that red side is still 2. But now it's not the run anymore. Now it's the rise. It's the vertical distance, which is pretty awesome. And the rise has now become the run. So it's still 5. The measurement is the same because the triangle is the same. We've just rotated the triangle 90 degrees. Okay? Now, the signs also changed a little bit. The run, we're always treating as positive, right? So it was 2 before, now it's 5. It's switched numbers, but it's still going left to right, still positive. But the rise before was negative. Now it's positive because I'm actually going up as I go from left to right. So my slope now is the reciprocal. It's 2 over 5. But it's also the positive value as opposed to the negative value before. So if we summarize what we just watched there, we're going to do some more examples in a second. What we've seen is that perpendicular lines have slopes that are what I call opposite reciprocals. So reciprocal meaning the numerator and denominator flip, because when I rotate my triangle, the rise became the run. And opposite, the signs flip. Because one of your lines is going to be going downward as I go to the left. One of them is going to be going upward, as I go from left to right. Okay, so you can see the slopes in this are negative reciprocals or opposite reciprocals. One is a negative value, one is a positive number. One has the 5 on the numerator, the other has the 5 in the denominator. One has the 2 in the numerator, the other has the 2 in the denominator. So reciprocals and then opposite signs. Okay, so now let's apply this to some other examples. So in here, it says, what is the slope of this line? So I've got a line drawn. I look at my scales first. My scales, it says this is 5. So that means each one has to be 1 for each box. same thing vertically. So both my x and y are going by 5. So if I wanted to find my rise and my run here, my rise is actually going downward again. So this is a negative rise. And we can count the squares. Because this squares, the scales are going by ones. I can count them. So 1, 2, 3, 4, 5, 6, 7. So my rise is -7. My run, again, always treating from left to right. This time I'm going 1, 2, 3, 4. So my slope for this one is equal to -7 over 4. If I write my equation first, like I should, by intro line, which is my formula, slope is rise over run. -7 over 4. Okay, so now if I rotate this and I want to find the slope of the perpendicular line, so again, that's what we had. We've rotated it. Now what's the slope? Okay, well, if we look now, the rise is the green line. It's still 1, 2, 3, 4. It's still the same size triangle. Triangle hasn't gotten bigger or smaller at all. So the red line is still 7, but now it's the run. And the run is positive. We're always going to treat the run as positive. And the rise is actually positive now, whereas the rise was negative before. So now the slope of this line is 4 over 7. Again, we should always start with our intro line, rise over run. Okay? So this, if we call this slope 2, and we look at slope 1, again, slope 1 was -7 over +4. So what's happened is the numerator and denominator flipped, and the numerator and denominator flipped there. So the 4 and the 7 switch spots, and then the signs are different. It's positive here, it's negative here. So one's positive, one's negative, and they flip. Okay, let's try another one. Actually, let's just summarize this for 1 sec. Nope, we're trying another one. Okay, so what's the slope of this one? You take a sec trying to figure it out. Okay, so hopefully you determined the slope of this one had a rise of 1, 2, 3, 4. Is that what you thought the rise was? Oh, did you check your scales first? Always check your scales first. Each one of these squares are going by 2. So that is not the rise. The rise is 8. Pay really close attention to your scales. Same thing for the run. Did you think it was 2? It's actually 4 in this case, because my x is going by 2s as well. X's and y's don't have to be going by the same thing, though, so you have to check both. Okay? I know that that's 2 because 5 makes 10. Okay, so now my slope, again, rise over run. So my slope in this case is 8 over 4. Oh, I see some of you being like, Ms. Brown, don't leave that as 5 over 4, or 8 over 4. That's reducible, right? Okay, so we reduce. We reduce to 2 over 1. That's good, right? No, that's not good. Why isn't that good? Oh, I can divide by 1? I can? Okay, so my slope is just 2. Slopes don't have to be fractions. If they're integers, make them integers. But if they're not integers, don't convert to a decimal, just leave it as a fraction. Okay? All right, so that slope ends up being 2. What are we going to do next? What we've been doing all day? We are going to rotate this line. How many degrees? 90 degrees. Here we go. 90-degree rotation. There it starts, and oh, I gotta click again. Boom. Isn't that cool? Just rotates. The whole triangle just rotated. It didn't get bigger. It didn't get smaller. The side lengths stayed the exact same. If the side lengths stay the same, then those are the same numbers in my slope. Run, in this case, is the red line. It's not the rise anymore. That's still 8, though. Red line's still 8. Green line, still 4, but now it's the rise. Okay, now we got to think about our signs. Run, we're always going to go left to right, so that stays fine. The rise, we're going up or down as we go from left to right. We are going down, so the rise is actually -4 in this case. So then, again, slope equals rise over run. Slope equals -4 over 8. -4 divided by 8 is -1/2. So again, if we call this line 2, line 1 our slope was 2. Those are opposite reciprocals. Even though one of them doesn't look like a fraction, I can think about it like a fraction, right? I could think about that like it's over 1. I just don't need to write that. But then it's flipped, numerator and denominator, and my signs are flipped. Okay. So now we're going to apply what we just figured out. So now we're not going to see any graphs until the very end. We're going to do a graph check. Okay. So it says, what is the slope of the line perpendicular to each of the line below? So let's make up some equations of lines, and we'll do a couple of them. Okay, so let's start with y equals 5 over 3x minus 7. Okay, well, first off, we are talking about slope. So I gotta figure out what the heck's the slope of this line. So I'm gonna call this line 1. That way we can refer to it. I'm gonna say slope of line 1 equals, well, the slope is always my coefficient on x if I am in y equals mx plus b format. You gotta check to make sure you're in that format, right? Okay, so my slope in this case is 5 over 3. So my new line now, we call that line 2, has to have a slope that is the opposite reciprocal. So first let's deal with opposite. It's positive to start with, line 1, so line 2 has to be negative. Now let's deal with reciprocal. So reciprocal means I have to flip the numbers. 3 over 5. Okay, we want to imagine this as just right triangles, not drawing a whole graph. 5 over 3, rise of 5, run of 3 would look something like that. Okay, rise of negative 3, run of 5. Oh, actually, I drew that last one backwards. There's no eraser here. Rise of, let's go over here. Rise of 3, run of 5 would be a triangle looking like that for my right triangle. Next one, rise of negative 3 means I'm going down. Run of 5 means I'm going like that. This line is perpendicular to that line. If I were to continue them up all over my page, that gets a little messy, but those are perpendicular. Okay, so my rise became my run became my rise, signs flipped. That's the big idea. Okay. Let's try another one. So again, we called that one 1. Let's call this one 3, just because we already did some work and we called it 2. Let's go with y equals negative 6x minus 2. Okay, again, we're just trying to find slopes. So we have to first identify the slope of line 3, though. Slope of line 3 is negative 6. Okay? We get that? It's the coefficient on our x. Okay, so our new slope has to be the opposite reciprocal. So our new slope, we'll call this line 4, I guess. Opposite sign, well, it started with a negative, so now this one's going to be a positive. And then reciprocal. Okay, well, reciprocal, you need fractions, right? So let's imagine this is a fraction. So the reciprocal, we'll flip it. 1 over 6. Again, if I want to imagine what this would look like, we'll try and draw it correctly here. Rise of negative 6. Go down 6 over 1. That one looks like that. Next one, rise of 1. So we go up 1. Run of 6 over 6. Like that. So now this line is perpendicular to that one. That looks good. Okay, again, that triangle rotated. Bloop, 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 bloop. Okay, Brown's getting silly. Let's move on to example 2 then. So example 2 says write an equation of a line perpendicular to the lines above. So perpendicular to 1 and 3. Okay, well, we found the slopes. We lost this one here. Let me just write this work back on. 5 over 3, slope of line 2 was negative 3 over 5. So if I want to come up with an equation of a line, again, using y equals mx plus b. That's the format we generally model in for most of the stuff we do in grade 9. Okay, so I know the slope of line 2 has to be negative 3 over 5. So I know for line 2, I've got y equals negative 3 over 5x, but then I don't know what my b is. I don't know what my y-intercept is. Well, I don't have any other conditions that I have to match. I just have to write any equation of a line perpendicular. You know how many equations of lines are perpendicular to line 1? An infinite amount of lines. right? I can rotate 90 degrees and then shift up and down all I want, okay? So I can put whatever I want for b. I can put 7. I can put 21. I can put minus pi. I can just leave it as 0. Doesn't matter. Let's just put 7. Notice it's not 7 because the last one was 7. The last one was negative 7. Doesn't have to be the same there. Could be the same. Doesn't matter. Okay, next one. For line 4. Now, my slope is 1/6 x. Again, whatever the heck I want for my y-intercept. Let's say negative 376. Because I like that number, okay? It's a good number. Deal with it. Alrighty, moving on. Last example today. Now we're given a little bit more criteria. We're still determining the equation. Okay, so that still tells me I want to start with y equals mx plus b. It's always a good idea, as you're reading the question, to kind of bring up some prior knowledge in your head. So I didn't even finish the question there. I know what the question is because I made them, but still, I said determine the equation of a line. The equation of a line, oh, that's y equals mx plus b. That's where my brain went, okay? And then it says, with the conditions listed, and then we're going to use Desmos to confirm. Yay, Desmos. Okay, so that's going to be perpendicular to this line. Okay, so perpendicular, what does that remind me of? That reminds me of opposite reciprocal slopes. Okay, so that's important. And so I got to identify the slopes, right? Okay, what is the slope of this first line? Slope of this first line is 3/2. Let's label this line again. Let's label it 1. So we'll say the slope of line 1 equals 3/2. Okay, so my new line, let's call my new line line 2. My slope of line 2 has to be the opposite reciprocal. So opposite. Okay, it started as positive, so now it's negative. And then the rise becomes the run becomes the rise. So we switch them around. Flip-de-flop, boing-de-foing. Okay? So now we know at least that equation 2 has to be y equals negative 3/2. Oh, wrote that wrong. Negative 2/3x plus, I don't know what my b is. I don't know what that shift factor is to move it up or down. I don't know what my y-intercept is, right? If that were 0, I would just have the equation of the line y equals negative 2/3x, so it would be going through the origin. But if it goes through the origin, it might not pass through this key point. I need to shift it up or down so it gets through that point. If I think about a sketch right now, going through the origin, down 2/3, down 2/3, that kind of idea. That's my line if b was 0. But I need to get this to go through 0.32. I need to get it to go through there. I need to get it to look like that. So I'm going to have to shift it up to this y-intercept, right? So I need to think about, okay, well, what is that shift factor? What do I need to add to these points in order to get up to there? That's what we're going to try and figure out now. All right, so in order to do that, we're going to sub in this point. So sub in 3, 2 to determine b. Okay, so 2 is my y, sub that in for y. Negative 2/3 is still my slope, I'm going to change that. 3 is my x, and the shift factor, or the y-intercept, is what I'm trying to figure out, the vertical shift. Okay, so now what I can do is, I'm actually going to do some reduction here. Because I've got, that's really 3/1. I have a 3 on the numerator and a 3 on the denominator. I'm going to reduce those and divide both of those by 3, and I just get 1. I'm going to make my life a little bit easier. That's going to be 2 now equals just negative 2 plus b. What does b have to be in order for that to work? Well, in order for negative 2 to get up to 2, I need to actually add 4. Or you can think about adding 2 to both sides to eliminate that minus 2. Right? So my shift factor actually has to be 4. So that y-intercept has to be 4. Now, I've already kind of drawn my sketch, so I've kind of validated my work already. But I am going to use Desmos to also confirm this. So we're going to flip to Desmos. I'm just going to click here. This Desmos is just desmos.com. It's not student.desmos.com, just desmos.com. You guys can use this when you're validating stuff for your learning snapshots or for any of your practice work and everything like that. But the key is that you still show all the algebra. You just go to Desmos when you need to check to make sure whatever your work is correct. What I'm going to do once I'm here is I am going to put all the key information from the question. So the key information from the question was y equals 3 over 2 x minus 6. So that was my original equation. Also in the question, we were given a point, 3, 2. So we said it had to be perpendicular to the red line, had to go through the blue point. And what we came up with was y equals negative 2 divided by 3. Whoops. Negative 2 divided by 3 x. Oh, do you guys see those whoop-de-whoops? The whoop-de-whoops aren't lines. In grade 9, we deal with lines. These loop-de-loops or whoop-de-whoops, you're going to start seeing in grade 11. So we're going to leave that for grade 11. The reason they're there, though, is because my x is in my denominator. That's a common thing that happens. So I need to get rid of that, so I'm just going to press backspace. And then I'm just going to use my arrow to get out of the fraction, but you can also just click. So x, and then we got a vertical shift factor, or a y-intercept of 4. So that brings whatever I get for negative 2 over 3x, I have to add 4 to that point. I have to then move it up, right? If I look at what this is without that vertical shift factor, negative 2 divided by 3, oops, missed my divided by. Okay, it's there. And then to get it up to that point, we have to go 1, 2, 3, 1, 2, 3, 4 up, right? That's why our vertical shift factor is 4. And that works for any point, really, on this line. To get from purple to green, you add 4. Okay, so my conclusion somehow disappeared when I was filming earlier, and I got too hot. So I moved down to the basement, and also my cat wanted to be in the conclusion. She thought it was important that we summarize up perpendicular lines. So Nisa Cat, this is my class. Class, this is Nisa Cat. All right, so in summary, perpendicular lines have opposite reciprocal slopes. So what that means, again, is the numerator and denominator flip and the signs switch. And the reason for that is because you're rotating at right triangle 90 degrees. So what was the vertical part, the rise, rotated 90 degrees, is now your horizontal part, your run. Okay? Yeah, that's your run. And then if you're starting with your run and you rotate it 90 degrees, it's now your vertical part, it becomes your rise. Okay, so you take your fraction, or you make it into a fraction if it's an integer by just putting it over 1, and then you flip it, you make it the reciprocal, and then you switch the sign. So if it was positive, it becomes negative. If it was negative, it becomes positive. That's the big idea behind perpendicular lines. Okay, Brown out.